So let's just talk about analog to digital conversion. Okay, this is ADC, and this is something that actually takes several clock cycles. It's order of the number of bits that you have. But if you look at this thing here, the gray line there is an analog signal, right? That's the actual signal. The red line is a crappy digital representation of it. Okay. Now the reason that, of course, this representation is so crappy is that if you look here, they've got one, 2, 3, 4, 5, 6, 7, 8 levels here, right? Okay, there are 8 levels here, and 8 levels are represented by 3 bits, right? That's a 7, 0 through 7, right? Okay, so the problem here is that the sample depth, we're talking about the depth of it. This is depth this way, okay? Depth, there's a P in depth, okay? The depth here is 3 bits, right? Even, crappy stuff is like 10 bits, and CDs are like 16 bits. Well, you can imagine with 16 bits, there's a whole lot more levels, right? So one of the reasons why this is so crappy is that we've got so few levels that we can represent this signal by, right? The other thing that makes this crappy is this thing here, right? This is the sample rate, and it looks like it's a very slow sample rate, right? Who knows what, I don't know what the time scale is, right? But if this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 or something like that, right? There's like 13 samples per second. A CD samples 44,000 times a second. So if you divide this up even better, right? If we divide this into many little things, and we have a more subtle way to represent the height of this, right? Then this thing is going to be much closer to that line. In fact, it's sort of like the pixels on the screen, right? If you could see the pixels on the screen, this line is not a smooth line, right? It's actually represented by pixels that are either on or off, right? Okay, here's an example. This is a sine wave, and I've represented, here's another thing about sampling, right? I've represented this with 10 samples. Now I've represented it with 25 samples, and you can begin to see that it's curved like that, right? But if you heard this, if this was something you heard, you could actually hear this little stepwise motion. You could hear the little deep, deep, deep like that. It would be a little high-frequency buzz, kind of like those greeting cards you get, right, that sing a song. They drive my dog crazy because they've got this sort of high-pitched whine superimposed over them. And that's because the sample rate is not very fast. Cutting down on the sample rate is like frames per second, right? It's a way to make something take less space, right? Here's 50 samples. It's like, ooh, that's looking smooth. That looks like a sine wave, doesn't it? Right? Here's 200 samples, right? And now it's starting to look like bad graphics, right? There we go. So a CD samples music at 44,100 hertz, right? There's a basic theorem. I don't know whose theorem it is, but if your sample rate is twice the frequency range, then you basically have the signal perfectly captured, right? And humans can hear 0 to 20,000 hertz, right? And so 44,100 is more than twice the sample rate. And then it's a 16-bit depth, which, gee, that's a lot of numbers you can get with 16 bits, right? So so CDs are good. But there are DVDs, right, that have an even higher sampling rate and a better bit rate, and you can hear the difference between those and this. And there are some real purists that say no. The true analog, like vinyl records, are actually better. Yeah, you have to buy a real nice turntable and a nice cartridge for it to be approaching better. But anyway, I kind of miss that hum and the buzz and the crackle of the records. Anyway.